Ah, summer. For many folks, it means trips to the beach, ice cream for dinner every other day, or pitching a tent in the great outdoors. For me, though, these long summer days mean outdoor cooking. Besides not heating up your kitchen, making the whole place smell like burgers, which may be desirable for some, cooking outdoors allows us to use a method that is not available indoors: smoking. Even if you've been living under a rock for the past 30 millennia, you probably have an idea of how this works. Smoke from smoldering wood is confined in a vessel where it cooks and flavors the raw ingredients, typically meat. Indeed, smoking has been used as a food preservation technique since very early in human civilization. Today, it is mostly used to achieve a unique flavor that tastes, well, smoky. Commercial grade smokers have been on the market for quite some time now, but the cost? Well, let's just say the smoke won't be the only thing making your eyes water. No, here at Adequate Bites, we are on a mission to provide you with all the tips and tricks you need, both in the kitchen and out, so you don't throw good money after bad. Enter the Flowerpot Smoker. This contraption can be easily made from hardware store components and put together in about an hour. If you want to get smart with it, though, some basic electronics and programming allow you to have a smoker that automatically regulates its heat, can be controlled from the internet, and even notifies you if it's running low on wood chips. Is it as good as a 12-hour smoked brisket? Maybe not, but it is. Adequate Bites. Adequate Bites. Alright, let's drop this Alton Brown bit. This project looked interesting when I first saw it, and I thought I would be able to improve it by adding some automatic control. This is a similar design to something like the Big Green Egg or Japanese Kamodo. The basic design has you place an electric burner in the base of a large flower pot, place a pie tin on the plate, wood chips in the pie tin, then suspend the meat above it somehow and place a lid over top. Simple, easy, cheap. My main goal for improving it was to add the ability to automatically regulate the temperature somehow. Before I got started on this project in earnest, I wanted to give the standard version a shot. This is the vision. The electric burner I bought was too big to fit in either one of my flower pots, which I expected might happen. In any case, I was able to test it by placing an empty can in my tin of wood chips and balancing another pie tin with my chicken breast on top. Alrighty, so this is going to seem pretty stupid, but bear with me a second. What I'm imagining, just for testing purposes, is we're doing a basic run. We're going to have the first pan down here, wood chips, and then the other one needs to be elevated above it. So we just put a can or something there. Then we can lid that. And how do you do? And I'm actually surprised at how well this worked. Despite what I said at the beginning, I don't really know much about smoking, and it shows because that was probably the driest chicken breast I've ever eaten. Anyway, with the theory confirmed, let's make some additions. My idea is to hook up a microcontroller, a thermal sensor, and a servo to automatically regulate the heat. And I'm hooking it up to Home Assistant because that's what I always do. First things first, we need to get the hot plate to fit into the flower pot. Taking the thing apart, it has just the complexity that I was hoping for. A heating element and a potentiometer wired up to mains voltage. The plan then is to take everything out of the chassis, hook the dial up to a servo, and let the microcontroller rotate it based on a temperature. Now, there is a problem with that plan that I didn't realize at the time, and it comes from a misunderstanding of how this thing works. We'll check in with that in a bit. The hot plate came apart easily enough, but I needed some sort of bracket to hold the plate a bit more steady in the flower pot. So I put together a crude bracket from some scrap aluminum. It's going under the plate, so it doesn't need to be anything fancy. And I printed a coupler to attach the servo to the dial. Again, rather crude, but we're not looking for fancy at this point. Shifting gears to the controls side of things, I'm using a Node MCU board because I had it and it's Wi-Fi capable. You could adapt this code to any board that supports Wi-Fi and I2C. I wrote a simple framework for connecting to MQTT, so I can listen to commands for changing the set point and report back various states. While I am normally all about local first control, I didn't want to have to worry about programming a 7-segment display or a potentiometer this time. To calculate the dial position, and thus regulate the temperature, I'm using a PID control system. PID stands for Proportional Integral Derivative, and is essentially an algorithm for modifying the input signal to a system given its current error. When you tune a PID controller, you change the coefficients used in the algorithm, which has an effect on things like how aggressively the system responds to error, how much it overshoots the set point, etc. There are no magic tricks to figuring out those values, and since I'm pretty new at implementing PID, I had to do a bit of guess and check. I found a piece of advice that recommends setting the I component to 0 and focusing on the P and D component until the error stops oscillating. Then, if the error is still consistently off, you can add some I component. It was at about this point that I realized I had made a really fundamental error. Realizing now that I'm a little bit of an idiot and I didn't really think about how this worked. So the dial here is going to just kind of turn that, and you can see the little switch going back and forth there. I didn't really think about how that might be a thermal regulator. It just either is or it isn't. I had assumed that the dial was some sort of potentiometer, but that's not the case. It's more of a variable thermal switch, and turning it changes the sensitivity. Kind of, not really. And how was it originally reading the temperature when it was in the hot plate? By having the thermal switch part of it in the chassis. So unless I want to try mounting that in the Flowerpot, we need a better solution. I probably should have realized this immediately, but I'm not much of an AC power guy. This was actually really good news. Knowing now that it wasn't some sort of variable input power and that the dial was essentially flicking it on and off, it took me no time at all to switch the design over to a relay-based system and use the same control scheme. The only difference now is that instead of the PID output controlling an analog input to the system, the dial position, it is now controlling a digital input, relay on or off. After I switched that over and a bit more testing, I finally did another attempt with some actual chicken breast. It took a little more tuning and I fixed some bugs as it was cooking, but I'm quite pleased with how it came out. Ooh, looking beautiful. Looks like we need some more wood chips, but we are looking good. But what about the smoked meats? I can happily report that it tasted not too bad. I didn't brine or marinate the chicken at all, but it was still flavorful, and it didn't taste like salmonella. The Flowerpot Smoker project has been around for a while, but adding a little bit of extra smarts to it makes it a bit more unique. I don't know. Let me know what you think, though.